When you see strange problems like this, try to think about where the water is coming from. So, if you count up all of the atoms and everything in the starting material on the product, you can see that we have 2 extra hydrogens and 1 extra oxygen. Okay, and that's what we're doing. We're adding water with acid catalyst. So remove this hydrogen, remove this hydrogen, remove this oxygen, and you can see that if we position our molecule in a kind of a roundabout way, we can see that somehow this molecule of water is going to interact with glutaraldehyde, and that's going to give us this cyclic kind of product here. Okay, so what are we going to do? Well, we first want to form, a hemiacetal on the left carbon, let's say. So let's take our starting material, okay? And remember, the general theme here is that when you have acid, you're going to use that in the first step of your synthesis. So I'm just going to draw H+ to keep things simple. There's a lone pair on this oxygen. It's going to protonate, and that's going to give us protonated aldehyde. Okay. And as usual, you would expect water to attack the electrophile. Why would it attack the left and not the right? Well, because it's protonated. It's more active. It's more of a electron sink, we could say. And so in this step, we're going to attack, okay? We're going to form this weird-looking intermediate, and we've got to sketch out all the rest of the carbons here. Aldehyde on the right is just hanging out, waiting to be involved. Okay, so we have that addition. So that's nucleophilic addition, all right? Now what we need to do is, fool around with some leaving groups and things like this. So you have many different choices at this point of the game. For sure, let's just deprotonate this guy here and make it a neutral molecule. So here, let's go ahead and take water, okay? And we've got some, lone pairs on this oxygen that could assist in deprotonating this guy here. And that would give us the next intermediate we can draw. So we call this a hydrate, okay, hydrate. Right, I won't draw a line to it because there's too many arrows at this point. So this is a hydrate, okay, where the carbon on the left has 2 OH groups, okay? So now what we need to do, so here's an OH group, right? I'll just randomly circle this one here, okay? And then what we need to do is somehow get another oxygen. Well, here I have an oxygen, right? I need this oxygen somehow to get connected to this carbon, okay? The carbonyl carbon, okay? So how would I do that? Well, I would protonate the aldehyde on the right and then get that circled oxygen to attack it. So let me do that, okay? So again, we'll use H+. Lone pairs are on this carbonyl oxygen, okay? And we'll go ahead and draw the protonated product there. Okay, now we have a very strong electrophile that's going to want to interact with a nucleophile. And remember, you can create any kind of nucleophile you want here. Here's a lone pair on oxygen that can then, attack itself like a dog chasing its tail in the park or something. And what you're going to get from this step is your cyclic molecule. So, you could count your carbons and be very careful. But what I'm going to do is I guess I'll be consistent with my colors and draw this in purple. Okay, so that we could kind of maintain focus on what's happening here, I'll use white to show this oxygen here, okay? And it's attacking this carbonyl, right? So there it's made that oxygen-carbon bond from that oxygen to the dotted carbon, and the electrons are going up to the positive charge, so that's why the formal charge goes away. And now there's a formal charge on the oxygen in the ring. So we're almost there. All we need to do is like deprotonate. I'm being lazy with, you know, removing these hydrogens. You don't need to draw this one that I'm underlining or this one. And so, you know, all you need to do at this stage is take water and deprotonate. Okay. And that will give you what I'm going to call the target molecule. So that's, you know, this one here. So how many steps is that? That's 1, 2, 3, 4, 5. So it's pretty typical, but this is a very challenging problem, and I just wanted to show it there in case you want to see something